what are the market drivers? Why are we, I think a lot of this might be known for a lot of folks, but some of the things that we're seeing out there, we're seeing it, that our guests are seeing it as well. Of course, the IRA has a fair amount to do with it. We're now seeing this investment tax credit around storage systems themselves, and that's helping drive sales, helping drive people being able to put this into place.
It's important to circle back and look at what are the returns for a given size. Would there be stronger ROI at this size or stronger net present value at that size? It's important to kind of find those numbers first before we dive into what, for engineers and builders, is the fun part, which is designing how to actually build the installation.
The reality is that as energy storage gets larger for a given installation, that return per kilowatt hour actually declines. And so you get to a break point if you're solving for an ROI, at which point it doesn't make sense to scale that system up any larger. The elegance of Yotta, of course, is in 1 kilowatt hour increments. We can take you all the way up to that break point and arrive at exactly the right amount of energy storage.
But if you think about some of the arbitrage and what it can do, there's other economic ways that these projects can pencil. And I think with unlimited cycling, you're able to do different things. So a good example, and what we challenge a lot of our EPCs, developers, integrators, is play offense with our battery. And what I mean by that is, can you find a cycle and a quarter or a cycle and a half? So maybe you're going to move 6 hours of renewables to the peak, but then you can buy energy in the middle of the night when it's the cheapest and use that for the morning peak. So now we've just delivered a cycle and a half. And so this is when the economics of unlimited cycling and a 25-year product really start to take shape.
It's not intended in any way to be used in utility scale applications. It's way smaller than that. So it's too big for residential. It's too small for utility. It's exactly right for many, if not most, of the CNI projects that we're seeing.
To build on what Chuck was saying about the cobalt-based chemistries versus an LFP, the way in which it frustrates me, the standards don't reflect different types of chemistries, the standards don't reflect different voltages, right? We're a low voltage architecture similar to microinverters versus string. So, there's an inability to arc our low voltage 48 volt battery, right? With cobalt-based chemistries, in the process of entering thermal runaway, it actually produces oxygen, thereby perpetuating the thermal runaway event, whereas lithium iron phosphate does not. So that is, when they talk about thermal runaway, it is literally like fueling the fuel, and that's what creates the danger. We actually don't even have sufficient oxygen in our product to maintain and induce thermal runaway, hence why I said that during thermal runaway testing, we didn't heat up above ambient. You can hold it in the palm of your hands while it's 500-600 degrees Celsius inside.